Have you ever watched John Wick? You know that feeling when he's completely surrounded, pushed totally out of his comfort zone, and yet he just pushes back with absolute flawless precision? Well, that is exactly the mentality you need for your Cambridge computer science exams. Welcome to this explainer. Today, we're not just studying, we are strategizing. Whether you're sitting for the 0417, 0478, 0983, 0984, 2210, or facing the absolute beast that is the 9618 syllabus, you know the pressure is real. Today, we are diving into an exclusive masterclass on object-oriented programming. OOP is notoriously tricky, but here's the secret. It's also entirely predictable because it appears in every single examination series. So we are going to perform a literal examiner's autopsy on this subject. We're ripping open past papers to show you exactly what the graders are looking for, and more importantly, how you can push back with perfect top-tier answers. Let's get into it.
Okay, let's quickly map out our strategy for today. We're going to cover the core OOP triad, then move into the procedural framework. After that, we'll look at the top examiner warnings, break down the method mark strategy, and finally finish up with evaluative thinking. Structurally, this is designed to get you inside the mind of a principal examiner. So, we have to start with the exact question that plagues thousands of students. Why is evaluating algorithm efficiency in OOP so incredibly hard? To explain this, I want you to picture two types of students. Let's call them Alex and Sam. Now, Alex is the memorizer. Alex overloads their exam paper with raw computer science facts, listing out every definition they've ever seen, but providing zero actual analysis. On the other hand, we have Sam. Sam rushes. Sam completely misses the specific command word requirements in the prompt and just throws code at the page hoping something sticks. Sound familiar? When you look at their flawed answers side by side, it's a sea of red pen marks, and that's because algorithm efficiency requires way more than rote memorization. The Cambridge Assessment Framework prioritizes analytical depth. You can't just know what an object is. You have to prove why it's the most efficient choice. Let's move to Section 1, the core OOP triad. These are your foundational pillars. Inheritance is our starting point. You likely know the basic definition, right? Passing down attributes and methods. But here is the strategy reveal for Cambridge exams. You need to decode the command words and apply the PEAL framework. That stands for point, evidence, explanation, link. Examiners actively reward candidates who can link this OOP architecture to other syllabus areas. So if your point is about using an inherited class hierarchy, your evidence is the code, your explanation is how it saves memory, and your link is how it perfectly integrates with, say, file handling techniques. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so remember, it's that logical, structured reasoning and those cross-topic connections using the PEAL method that will instantly elevate your mark.
Next up in the triad is polymorphism, and this brilliantly illustrates a core Cambridge philosophy. Polymorphism isn't just theory, it's a massive test of how adaptable you are. The syllabus explicitly states that top-performing students must show conceptual understanding that transfers to entirely unfamiliar exam contexts. Think about our rush student Sam. Sam sees a totally bizarre real-world scenario, maybe a smart grid energy management system, and panics because it wasn't in the textbook. But if you apply the PEAL framework, you stay grounded. You state your point about how polymorphism allows different power nodes to be processed dynamically. You provide the evidence from the scenario, you explain the processing logic, and you link it back to system efficiency. That is how you handle the unexpected.
Rounding out the triad, we have containment, or aggregation. This is a specific has-a relationship. Now let's talk about transformation. If we take Alex, who just writes, containment is when a class contains an object of another class, the examiner just sighs and reaches for the red pen. To get the green check marks, you need deep analytical reasoning. You have to provide evidence-based reasoning for why one object absolutely must contain another in the specific system you're designing. You need to analyze the life cycle and dependencies. It's about showing the examiner the why, not just the what.
Now, what's really interesting here is how this maps out exactly what examiners are looking for across different cognitive domains. Knowledge and understanding, that's just your baseline. It's the bare minimum. Application is where you start connecting concepts to those unfamiliar contexts we discussed. But analysis, that is the absolute peak. This is where you are actively evaluating alternatives. Why use containment instead of inheritance in this specific database?
Proving you know the trade-offs is how you beat superficial breadth and grab those top-tier marks. All right, knowing the theory is only half the battle. Let's look at Section 2, the procedural framework. When tackling complex algorithm questions, top students systematically follow a blueprint. Let's call this the Computer Science Success Blueprint. It's 5 procedural steps to ensure you don't miss a single command word requirement. Step 1, deconstruct the question. What is it really asking? Step 2, extract relevant data, like specific object attributes or binary constraints. Step 3, select your analytical framework. This is where your peel method comes in. Step 4, execute your solution with beautifully clear notation. And Step 5, present your final answer using the correct Cambridge terminology. If you follow this blueprint, your answers transform from a scattered mess into a highly targeted point-scoring machine.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, jumping back into the execution phase of that blueprint. Your practical application must explicitly demonstrate these 4 programming skills to capture all available points. You need step-by-step decomposition of the problem. You absolutely must justify your appropriate data structure selection. Your code implementation needs to be widely efficient, and you have to prove you know how to perform a rigorous testing. This is exactly what separates an average answer from a flawless one.
Section 3, Top Examiner Warnings. Let's analyze direct insights from the Principal Examiner reports. Welcome to the interactive workshop part of our explainer. I want to test you against the top 3 exam traps. Imagine a 60-second countdown timer on your screen. Challenge 1 is a data scan. If I show you a complex OOP data table and you just throw a standard sorting algorithm at it without checking the specific context, you've hit mistake number 1. You have to extract the core trend first. Challenge 2, find the flaw. Say a student writes a paragraph about array limits but completely ignores what happens when the array is empty. Boom, mistake number 2. Forgetting boundary conditions and edge cases will tank your score. And mistake number 3, providing generic answers. If the scenario is an airline booking system and your code just says Object A and Object B, you're losing marks. Tie it to the context. Section 4, the Method Mark Strategy. This is the official safety net you absolutely must utilize. This examiner alert is arguably the most vital takeaway of this entire explainer. Students lose marks by not showing working. Let's do challenge 3, speed writing. If you had 30 seconds to write one perfect peel paragraph, the most important thing you can do is make your procedural working visible. Let's say you mess up the final line of your code, or your final binary conversion is wrong. If you just write down the final answer, you get a 0. But if your step-by-step decomposition is written out clearly, examiners can follow your logic. They will actually give you method marks to save your grade. Show your working every single time.
Section 5, Evaluative Thinking, for those aiming for the very highest grade boundaries.
Let's do a cheat sheet recap by comparing these 2 approaches. Think of Alex and Sam's standard answers on the left. They identify the info, they attempt a basic systematic solution, and they stop. It's okay, but it's not great. Now look at the top scoring answer. This is the John Wick approach. You consider multiple solutions. You analyze the trade-offs, like processing speed versus memory usage. You acknowledge the limitations of your own code, and you justify every single architectural decision with hard evidence. That is how you dominate the mark scheme. This is the ultimate deconstruct, solve, evaluate, problem-solving loop. It boils down to 3 rules that guarantee top marks. Rule 1, command word decoding. Know what you're being asked. Rule 2, peel framework application. Structure your logic. And Rule 3, a time management matrix. Don't rush like Sam, but don't get bogged down memorizing like Alex. Identify and break down the info, solve it systematically, and then check for reasonableness and make justified recommendations. Examiners are practically begging to see this loop in your paper. So take this framework and apply it to your next practice session. Completely transform how you approach these problems. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.